All right, let's begin. Thank you everyone for joining and welcome to our presentation today, Visualize All the Data. My name is Sam and I'm in the sales team at Cambridge Intelligence. My background is that I started as a developer many years ago, but have since moved into the commercial side of things and joined Cambridge Intelligence to look after our clients in Europe, Middle East and Africa. I'm joined by Christian, who will be presenting today, who you can see has had many years of experience in network analytics. So don't let that photo fool you. He's a lot older than he looks. For the last 2 years, he's been with Cambridge Intelligence, applying his experience to helping customers and others that are interested in KeyLines to build visualization, data visualization applications. And an element of that has been to connect to various data sources, which is what he'll be discussing today. So after these introductions, I'll hand over to Christian and he'll go over a few data sources that you can connect to. So he's looking particularly at non-graph data sources. So he'll be looking at files, different flat files like CSVs, Excel files, things like that, various databases, again, non-graph databases, and then APIs that can expose your data securely. And then he'll finish off, he'll look at some ways to interact with your data in different ways as well. And we'll finish off with some Q&A, so there'll be a chance for you to ask questions. In fact, please, during the presentation, feel free to type your questions and send us your questions while we present, and we'll gather those and ask them at the end as well. So as part of Christian's presentation, he'll be demonstrating some visualizations as well. So before I hand over to him, what I wanted to do was describe the software that he'll be using to do that visualization, and that's KeyLines. KeyLines is a JavaScript SDK, so it's a component that developers can embed into their web applications to visualize connected data and then make that available to other users. And those users can be in the same company, or it could be to their customers. And in doing so, they will make their data visible to others. We've created KeyLines from scratch ourselves using JavaScript, so we know it works across all modern browsers on all operating systems, and that includes those with a touch interface. And KeyLines provides powerful functionality with very high performance. A big advantage of KeyLines as well is that it's easy to use. So all of that together means that it's very quick to learn, and developers can very quickly build a powerful, beautiful visualization and rapidly deploy that to their users. So with that, I'll hand over to Christian and he can start his presentation.
Great, thanks for that introduction, Sam. It's great to be speaking to everyone on the line today. Thanks for joining us. I'm looking forward to some questions at the end, but I'll get started. So first up, I've been with Cambridge Intelligence for nearly 2 years now, as Sam said, and I was looking at my records, and it looks like I've spoken to at least 500 customers around the world since I joined. And one of the most exciting things for me about my job is that I talk to customers who are working with often quite different databases or different backends or different data sources. And I find that really interesting. It's also really interesting to see over time what has changed in the landscape in terms of databases that people are using, and the types of data they want to visualize, and how that looks in modern KeyLines. But for the presentation today, I put together a bit of a diagram that summarizes all the different data sources that I've seen. It's kind of it's not complete. You know, there are some things that I see in the wild that isn't on this slide, but I think it sets the stage for what I'm going to be talking about today, and I'll refer back to it a few times as I walk through the presentation. So here we have 3 separate bubbles describing different types of data sources. Some of these logos may be familiar to you, some of the file formats may be familiar to you, and I've kind of grouped them together in the typical way that you would group these together in the technology space. So on the left, we have file formats. So these are, of course, files that you have on disk. That's what I like to say about them. They're on disk, they're on your computer. They're often sitting there on your computer, and you maybe want to leverage them in some sort of application. The most common ones you probably see are things like CSV, Excel files. These are really the sort of bread and butter of your sort of data sources that you have on hand in a business context. On the right, databases are more about storing data in a reliable way for retrieval. And we have a wide array of databases being used by our customers. I'll go into a little more detail on the categorization of these databases but some of these logos should also be familiar. So from Oracle maybe, or the open source Postgres database, for example. And then in the middle, it's kind of helpful to delineate these as a separate thing from a database, although they are kind of converging in 2018 in some ways. But search indexes are another way that we could be working with data. And these often really prioritize fast retrieval of often quite complex data. It's kind of basically a trade-off of space on your computer versus a more efficient way of storing it with a database. But one of the key distinctions that I'll be talking about today is the fact that you can have file formats, you can have databases, and you can have search indexes, and they can either be connected or non-connected. So I would classify all of these at the bottom as connected data sources, and that's what I'll be talking through today. This isn't as clear-cut as it could be potentially, because there are some databases that you can see in the green bubble on the right that actually do start to work into the connected data definition. But I think this is a nice little summary of the sort of landscape of data sources. So Sam gave a little bit of a background on this, but what do I mean when I say connected data? We talk about connected data. We often also call it networked data, or graph data. But at its core, I think the Graph 101 view, the connected data 101 view, would be something that looks a little bit like this. So we have nodes, which can be points in effectively objects or people or places or points in time, for example. They're also sometimes called nodes, vertices, for example, as well, or entities. We have links that connect between different nodes of different types, maybe of the same type, in fact. That's in the middle there. They're often also called edges or just relationships. And then often in a connected data context, we have things called properties, which sit on either the links or the nodes themselves. And I've just put one there on the node on the far right there. Just as an aside, most of the customers I speak to are using property graph databases, and that's really the world I live in. I'll talk a little bit later on some of the alternatives to what is known as a property graph database. So that's the kind of boring look at what a real basic network would look like with a node and a link. But what is it actually in the real world? I've got some sample examples here. So we work with customers who are using connected data in a compliance setting, maybe looking at businesses and how they're connected to each other. Cybersecurity, so watching for threats or firing off visualizations that show potential threats that are happening maybe in real time. IT management is really interesting. So we can take what is typically quite a manual process of drawing a network, of showing all of my devices and how they're talking to each other. With the graph visualization technology, we're able to do that in an automated fashion and have an interactive experience when looking at that sort of data source. And then finally, for this slide on the right, we have law enforcement. So this is a real traditional use case of graphs or link charting or networks. Here we have a little example of cell phones and communications. So maybe looking for maybe criminal activities and using these sorts of visualizations to make some sort of decision. So that's from a sort of business context. Really, in a little bit more technical detail, here's a real simplified version of what this chart would look like in KeyLines. This isn't quite correct. I've kind of hidden some of the things like colors and things like that. But this is really important as I'll talk about how we build up these connected data diagrams. So on the far left, this is all you would need to define what is known as a node. All you would need is an ID and the type of node. This is JSON. It's a really commonly used file format, often on the web. And as I say, it's really, really simple to come up with an idea of what a node is just by using the ID there and the type. On the far right, we have another node, and I've actually put the property that's shown on the chart there as well. So with KeyLines, you're able to put any sort of properties that underpin or basically in your data, and you're able to put that as part of the chart for use in the future. So there in the D element reserved for data, I put the property of property. Now, links are a little bit more complicated in that there are two IDs you need to take care of. And these just effectively say that you are going from one node to another node. So ID1 is the source node and ID2 is the destination node. And here we're giving it a unique identifier for that link itself as well. And this is important if there are multiple connections between two nodes, as maybe you want to show those as separate links. So KeyLines is very much data source agnostic in that we are allowed to specify the ID as whatever we want. And I'll be coming back to that in a second. So as I say, this is quite a simplistic view of what it means to be connected data, but this is certainly the sort of data that you'd be working with KeyLines. Now, looking back at my diagram here, we see that there's a whole bunch of things that are grouped together as connected. But what happens if your data isn't connected at all? I would say that these are, in principle, non-connected data, and that's actually kind of an interesting one. Non-connected was something I kind of came up with for this because there's also disconnected, of course, or unconnected. Those can have different connotations when we're talking about databases or even search indexes. So I think non-connected kind of gives you an idea that we're talking about the sort of connections within the data rather than worrying about actually how we're connecting to the data at all. But I've come up with a definition of what it means to be non-connected. It's kind of vague, but connected data model needs to be derived. So we have some sort of data and there isn't some sort of explicit understanding of what it is connected in that data source. So I've mentioned how CSV and maybe Excel files are maybe the most common sort of data sources that people would be using in businesses. So I'd like to work through an example of using a CSV file and showing how I would derive the data model or the connected data model to come up with some sort of visualization. So this is just a standard example file that somebody might have. It shows connections between hosts on a network. It has a little code there for the payload, but it's kind of hard to read in this format because it's a CSV file, it's just a text file. We also have a date time at the end there, so there's some sort of property about each of these connections between these hosts. But I'll do what most people would do with this sort of data source, kind of for against our sins or whatever, but we put it straight into Excel because it helps us to put it into the columns there so we can see it a little easier. Now, I always like to think of sort of analogies for when you're working with data. And what I've come up with today for an analogy of converting this non-connected data into something that can be visualized is really to Snowball. So here I will start with my data at the top. I will start with the top record there. And as I go down the data set, I will basically be picking up IDs as I go along. I'll be looking at each row and I'll be saying, this column should be used as an ID and this column should be used as an ID. And by virtue of them being on the same row, I'm saying there is a connection between those two IDs. So you can think of the snowball kind of rolling from top to bottom here. You only need to read through the data set once because you're just effectively adding new data as you go along, and you're kind of maybe even replacing data with new properties that are for the same nodes and the same links. But I think it's quite a nice analogy for thinking about how you basically are just always looping through this data set in order to build up your model as you move along. So let's walk through that in a little more detail. So by choosing this column as a host column, I can say that this derives my ID for each of my nodes. So we see there that service 4, service 27, these are all going to be used as the IDs as I showed you on that previous slide. And those will be turned into nodes based on those IDs. I can do the same for another column, and I can derive separate nodes based on that column itself. So you probably can maybe spot here that this column maybe would have overlapping IDs with the first column. And actually, it doesn't really matter for our purposes for converting this into a connected data source, because once you have an ID, you're effectively just going to be overriding the previous ID and saying that this is the same connection or this is the same node as before. It's really in your hands how you would derive those IDs. And again, by virtue of these being on the same row, we're going to derive that there's a connection between these two hosts. And you can kind of imagine us snowballing down this data set and saying these IDs are connected, so therefore there should be a link between them, and that's shown there on the right. And then properties, any sort of item or any sort of property in that data set on the same row can be added to the data set as part of your node or your link. Here I'm saying that I would be maybe adding my date times as a property on the node. It's actually more likely that I want to be aggregating or kind of collating together all of those date times for each of the links for which I have a unique host 1 and a host 2. But the connection type would probably be something I would put on the link as well to tell me the way that I'm connecting between these different nodes. So it's a little hand wavy, but really what I've done there is I've taken what is kind of a flat file on disk, a CSV file that is really hard to work out what's going on in it. And I've come up with a set of data that will be able to be visualized in a tool like KeyLines. So let me show you this in the real world. So that data set has been brought into our demo here. And I've added some extra nice colors. We've got our nice gradiented links feature that we added recently. So if I zoom in here with my scroll wheel, you can see that there's links and you have a nice gradient from the color of the source node, so host 1 over to host 2. But this is our first look at KeyLines in a live setting. So we have a nav bar on the top left. I can always click on this to maybe show the whole chart again. And I can go full screen at any time as well. I really like this demo because it shows how with very minimal interaction, we can actually have quite a compelling experience when we look at data. So in this data set, now that we've brought together all those links based on the CSV, if I select a node here, say the SAN unit, we have an interaction event that says, as a result of selecting that node, only show me the nodes that are downstream from that SAN unit. So now I see all the things that depend on that SAN unit. And KeyLines has a number of different layout algorithms to show off these connections in a way that makes sense for my domain. So I can turn on our radial layout here to put that SAN unit right there in the middle, and I can see what's downstream from there. So just by doing that basic transformation of my CSV into a visualization here, and then exposing these interaction events, I have what could quite easily be a product. I can take any sort of CSV that's in the same format, and I can say, here's your view of your data set, here's where the hierarchy is, and then here's the dependent nodes on each of these nodes in your network, for example. And I should probably stress that KeyLines is generic, so I've been talking about networks a lot today, but we can really be using any sort of connected data as long as you have some sort of idea of what the model is. One other thing I like in this demo is that I can turn on an impact analysis. So if I turn that on here, we can use all those connections again, and we can derive the most important nodes. And unsurprisingly, in this data set, the SAN unit is the most important. So that's there in the middle, and now it's been resized to match the number of nodes that are downstream from it. So popping back to my slides, just one caveat when I'm talking about this sort of a conversion from CSV. I think for the vast majority of customers who maybe aren't familiar with connected data and they're just starting out with working with connected data, I think working with CSVs like this and thinking about what columns should represent nodes and which columns should represent links maybe or properties, I think it's a great way of getting started. And I think in some use cases, if you do have those files that are already generated for you, it may be quite reasonable for you to be using that as the backbone of your application. The other benefit to it is that, because you're working in quite a flexible way with a raw file, it actually means that you can play around with the model and you can get an idea of what the model should be based on that data. So before worrying about having a database for your volume of data that maybe would be larger than can be worked with a file, you could say work with a smaller file and play around with different columns to work out a model that makes sense to your end users, as that's really what you're working towards. You're working towards having an application that allows people to make decisions when they look at your data. Oops. So going back to my slides here, we're going to look at the common data sources again here. And now I'm going to focus a little bit more on the connected data piece of this. So I'm going to subset those down. And when I talk about these file formats, these indexes and these databases, these already have an idea of where the connections are already existing in the data set. They're kind of what I would think of as explicit in the data set. I'll go through a file format example in a minute. Some of these aren't particularly familiar to a lot of people, but they're a great way of representing connected data on disk. Elastic is an interesting one. So with a product called Elastic XPack, there's a sort of graph module in there, and that takes what is a pretty good search index and kind of supercharges it to work with graphs. And that's another example of how things can be a little complicated when it comes to real world uses. But we have some selected logos here on the right for databases, and I'll be talking about databases in a second. But graph databases are very popular, especially Neo4j here on the left. So when we have connected data sources, like a dot file, it's actually really trivial to get that into KeyLines because we already have defined explicitly what those nodes and links are. This looks kind of complicated. Dot files, or rather GraphViz as an application, as an open source application, has been around since 1991 at least. So this technology really does go back. I won't dwell on it too much, but we have a nice definition of nodes and links here in this what is often known as kind of ASCII art style, where we say there's a node here and it links to another node here. And then using this tool, we have a static, so it's not interactive like that nice KeyLines demo I showed you, but it's a nice static view of this data that's been nicely connected in place. So let's focus on databases now. We get a lot of interest from people who are trying out graph databases for the first time, but we also have a number of customers who are using them in production in a very highly scalable way. And the thing about graph databases is that there's an awful lot of them. I've updated this slide. I had this slide from a few years back, and some databases have dropped off the map. Two kind of relatively new databases that people are finding interesting are MemGraph from another British company, and TigerGraph down here. And it is kind of hard to keep track of all of these databases. They all have their kind of unique selling point in some way. and people strive to kind of categorize them and say that certain databases are better for certain reasons. But again, at Cambridge Intelligence, we really don't mind what is in the back end. We just say if your data has some sort of connected element, then you can work with it in KeyLines. So when we think about that slide about all those databases, people sometimes ask me, how do I kind of pick those apart? How do I work out which database is right for me? And I would always point towards maybe not worrying about a graph database at first and starting with some sort of flat file sort of approach like I've shown you today, or even a relational database where you can treat it as I did with that CSV file. But here's just some factors to consider when we think about different sort of data sources. So first up, I mentioned this already. I'm kind of focusing on property graphs a lot today, but there's something else called a semantic graph, so to speak, or an RDF graph. Some people would say that these are superior to property graphs, but on a high level, it's still talking about connected data. We're still talking about these really interesting ways of looking at and working with data from a sort of connected fashion. But you may have people on your team who are more aligned with the sort of academic RDF world, and that might be something you want to consider. Scalability. Now, a lot of databases make a lot of different claims on scalability. It's something that's quite important. It effectively means how will your database grow along with your data? If you look ahead to the future, how much extra data will you be working with, and how will you ensure the performance of your database as you start to add more data? There's such things as horizontal scaling and vertical scaling, and different databases kind of define how they work with that in different ways. So that's definitely something you want to look into, especially in comparison with how much data you expect to be using. Getting a little bit more technical now, but some databases, or at least graph databases, try and reinvent the wheel to come up with a query language. So the language in which you query against the database, they come up with a query language that closely matches connected data. Now, other databases think that SQL, is probably the most popular query language in the world. They think that the graph sort of connected view, you should be using a sort of extended version of SQL for that sort of data. So there's upsides and downsides to different approaches. Using SQL will mean that the developers with experience in that will just need to get their head around the graph part, and they should be away. But maybe that isn't quite as efficient to work with or to reason with as a kind of query language that's been built from the ground up to work with a graph database. And I'll talk about some of those in a second. Some databases are free or open source, but you should always consider the cost of ownership of those databases. You might be pleased that you're not paying anything for your database now, but if it crashes one day in the future and there's no one to turn to on that, which leads to my last point of support, you can actually find yourself spending a lot more than you would have done getting some nice support agreement with one of the database vendors as well. But always look out for the cost or the cost of ownership with those databases. Now, we have a number of graph databases demos on our SDK site for KeyLines, so I want to walk you through a couple of those now. Here is our SDK site. We do offer free trials for anyone who wants to give this a go with their datasets. And as you can see here, a lot of the most common datasets you'd want to use with KeyLines are represented in a live demo on the site here. Now, I would say that Neo4j is the most common graph database that people come to us with. I believe the market share is maybe around 30% or so in terms of graph databases. I could be wrong on that. But here is a demo with Neo4j, and we're using the Internet Movies database here on the left. So on the right here, we have a query that has been run against our database. And this is an example of a cipher query where we're saying match these nodes with this link to another node. In Neo4j, they call links really relationships. But you can kind of spot here that there's kind of like an arrow here that represents the connection that you're querying against from the database. Now, this query is a little more complicated than just a basic sort of select query from the database. And that's because we've also brought forward these little plus icons to say, hey, there's more data in the database if you so wish to add that to your view. So going back to interactions with KeyLines against databases, if I were to double click on one of these nodes, let's say Hugo Weaving up here, we'll run a new query against Neo4j, and you'll see here that the query has been updated with that new query that I ran because I double clicked on Hugo Weaving, and I can see all the movies that Hugo Weaving's in. I can do this to my heart's content and run fresh queries against the database on demand, like so. And I can keep doing this, and it's a little funny in a movie context. It's more sort of a trivia view, but in the real world, you may be looking at, say, criminals and how they're connected by police officers potentially, or so on and so forth. The use cases for this sort of exploration approach is pretty much unlimited. And one thing that I'll come back to in a little bit is the fact that I'm not making kind of rampant animation changes all the time just because the chart is on the screen. And what I mean by that is now that things are being added incrementally, there's a lot of overlapping, but I haven't forced a new layout by default because that can be a little disorienting for end users. So now that the data is being brought back from the database and it's showing on the screen, I can run a new layout by clicking on the buttons here. And now I'm using our standard layout to minimize the overlaps in this data set. So there I can see all that data brought back from the database shown on the screen like so. Now, going back to the databases page, I can choose any of these other databases, and there may be a little bit of, let's go for ArangoDB. There may be a little bit of deja vu. This is also the movies database. And the nice thing about these demos is that they're all using the same data source. So because we're data source agnostic, you can move between these. You can look at the source code, which is available in all of these demos, and you can see the ways in which they differ per database. Now, one of the reasons I like ArangoDB is that they have what is known as the Fox framework, which means you can write little programs that sit on the database, and they can do that sort of snowballing conversion that I showed you earlier, right there on the database as an endpoint. So you can just query, in this case, an endpoint provided by the database. So here I'm just querying as the endpoint, and I'm getting the data back based on that query that I have here with the matrix. So that's just one example of how databases differ. The Neo4j connection is using a protocol called Bolt, which is quite nice. But Arango, we're just using a REST API call against the Fox endpoint that I've created to convert data from the raw database format into KeyLines format. And just like before, I can double click and I can expand out and show new data like so. Now, I gave a bit of a mention for APIs there. APIs are interesting in that, really we can leverage any sort of data that is exposed with an API in KeyLines. Traditionally, we would be using what's known as a REST API. I won't go into detail of what that actually really means today. But effectively, just like that ArangoDB demo, I'm querying against an endpoint. Like in this case, we're querying against the GitHub API, showing us the posts, comments, and authors for different issues on the website GitHub. And we're doing queries against there. And we're feeding them into our KeyLines application based on those queries. I thought it was prudent to note there's something else in the world now called GraphQL. It's important to note this because it's not quite as connected to graphs as you might expect. Although confusingly, there are some databases who claim to have query languages that are based on GraphQL, but that's just really confusing things quite heavily. But here in this diagram, we see that there's a little bit of a difference between a REST API and a GraphQL API. And some of the reasons that it's different is that we can query and we can selectively say the certain type of data we want to bring back with one query request rather than going against an endpoint and having to subset the data returned back locally. So in this case, we're doing one query and we're saying there's posts, comments, and authors in that same query, and we're reducing the number of round trips against our database. But in a web development context and working with KeyLines, which is a JavaScript toolkit for the web, really you're doing the same sort of snowballing technique because APIs are typically not implicitly connected like the data sets I've shown you today. So you are still going to be running through those, working with the IDs and coming up with the model based on the data being returned from the API. Now, I want to just finish off by talking about two different approaches that we often get asked about at Cambridge Intelligence for working with data. So first up, I call this dynamic data, and I gave you an example of that with the demos I showed you of the different databases. So what this means is I do a query against the database, and as a result, I get a payload or results from the database, and I convert that into KeyLines format in the browser. And that is often known as kind of a pull request. So I'm doing a pull against the database, and I'm loading that into KeyLines. We get a lot of interest from people trying to do this in a more of a sort of synced fashion. So more of a push from the database to the visualization, kind of on demand from the database's point of view. So what happens here is you often would set up some sort of WebSocket connection. So there's a live connection between your web app and the database. And whenever there's new data, you want to be adding that to the screen, basically as it's being added to the database. Now, I talked about this with the database demo itself, but I think this is a little bit of an anti-pattern when we're working in the browser and working with applications that are helping people, because often you find that there's the data volume that you're working with is going to be trying to append too much to the screen at once, and you can get pretty overwhelmed by maybe alerts being added or fresh logs being added to the screen. So one strategy I recommend for this is having some sort of valve, so to speak, or a big button that says, FYI, there are 5 new alerts that have been fired. Do you want to add those to your view? Are you ready to show them in KeyLines? And that's quite easy to do with JavaScript. And then I call this the hybrid data. So, I've been talking about lots of different data sources, lots of different file formats. And there's no reason why you need to limit yourself to one database choice. And in fact, a lot of the databases that I've shown you today have what is known as a multi-model approach, in that they host data, or they house data in different formats depending on the type of data that you have. So as a result, you can use the same database in multiple ways, or you could use different databases for the purposes that they say they're best for, and you can actually query against them separately. So in this case, maybe I'm using, sometimes I call it tombstone data, so basic data, so basic core connected data, or like names and addresses, or date of births, for example. These things are kind of the raw data that you maybe want to bring to your visualization in order to show the core data. But you may want to farm out other requests to a search index. Now, search indexes are more suited for maybe more textual data, in which entities have maybe been extracted out from, or large blocks of text have been loaded into the index. So you may want to, as a result of loading your data into KeyLines, you can maybe select a node and then run the ID against your search index separately, so that you're not having a bottleneck on your database, and you're retrieving the data from the search index a lot faster for maybe things that should be shown on a side panel or shown there in your browser. So that brings me to the end of my slides for today. As you can tell, there's an awful lot to talk about in the landscape for graph data, or connected data, and even non-connected data. I'm always happy to talk to people who are interested in visualizing their connected data, even if it's in Excel files or whatever. And I really want to help people as they start that journey along the road of working with the graph database and working with connected data. I'll hand back over to Sam now, but thanks again for your time, and I hope this session has been informative.
All right, thanks a lot for that, Christian. It was a really good presentation, and good to know that, if you want to start a visualization as well, you can start it with Excel files and things like that. You don't have to have a full graph database all set up and ready to go. So we have a few minutes left, so we can go through a few questions that have come up through the presentation. For one that's come through is someone was quite impressed with the connection. So there's a whoa, how do we get from Excel to KeyLines, asking what's the upload workflow to get from, say, something like Excel or CSV to KeyLines?
Yeah. So Excel is a little funny in that it is a proprietary format, right? So often, people would like to be exporting to CSV because most programming languages will be able to work with CSV. Often in the real world, when people send me Excel files to start along the path of working with KeyLines, I would use a JavaScript library that allows me to talk to that workbook. Now, Excel is a little brittle. It is a little funny, if you change column names, maybe your translation process from that file into KeyLines would maybe error out in the future. So I wouldn't recommend it in any sort of production usage. But as I've kind of mentioned today, working with that flat file on disk can give you a good idea of your data and what would make a good data set. But I'm happy to take offline how, or even share some sample code of converting from those files into KeyLines.
Great. All right. And I guess connected to that, then someone was, and you just mentioned it there, is it possible to use CSV files with KeyLines?
Yeah, so I'm pleased that I think I've probably covered that in the presentation. KeyLines is JavaScript, and really the kind of de facto data format in JavaScript would be using JSON, which I gave you some snippets of today. There are a number of libraries to convert from CSV to JSON, and then it's just an extra sprinkling of code to convert that into KeyLines format. So yeah, CSV is I think the most common sort of data source that you maybe would see in the real world, and it's kind of analogous to logs as well, regardless of whether it's a comma separator or whatever it's delimited by. But yeah, certainly you can use CSVs.
Cool. All right. Another question that's come through is, can I use KeyLines to write back to the database?
Yeah, I get this question a surprising amount, and you can, yes. I mean, as you saw today, I can query against the database, query against an endpoint, and I can get results back. There's no reason why you couldn't open up write access to your database, so you can do the same sort of querying, and as a result, make commits up to the database and changes. I often recommend that, with great power comes great responsibility. The hardest part of that is that you often don't want to be exposing writability, especially if you're talking to a source of record. You don't want to be exposing that capability to just anyone. And there's often repercussions in terms of moderation of updates to the database, as well as access levels and things like that. So it's certainly possible, but it's a real headache. So I would definitely kind of walk before you run and focus on visualizing the data first before using it as some sort of database update tool. But yes, it is possible.
Right. Okay, and all right, this one's quite a common question as well. What are the practical limitations of visualizing objects, as in how many, and the amount of memory available for browser objects?
Yeah, I'm not sure I get how the second part connects in there, but let me just talk about this in general. So KeyLines uses a really performant way of rendering to the browser. It uses something called WebGL. WebGL takes advantage of the GPU in your computer, if possible, and it has a really high throughput of data to the screen. More traditional ways of looking at data in the browser would be, say, through SVG or Canvas, but WebGL really superpowers or supercharges that view in the browser. So it can work with a large amount of data that's not really possible from before. The thing about this as well is that it guarantees a real smooth experience. We talk about frame rates quite a lot when we talk about performance in the browser. With WebGL, KeyLines charts of maybe up to tens of thousands of nodes would be smooth when you're panning around and zooming around in them. And we think that's really important for a really useful experience when visualizing data. Now, your mileage will vary. It will depend on your laptop capability or your computer capability, the browser you're working with, the kind of age of the browser, so to speak, the platform, and so on and so forth, and the memory in your machine. These things will all feed into how much data you can show on screen at once. So I would certainly say the best thing to do would be to try it out yourself. It's always a moving target, but the nice thing about that is, though, that things are continually updating and changing. So we keep an eye on performance in KeyLines and make sure it's as performant as possible. And in turn, the browsers and the computers get faster and faster, so things kind of slowly improve anyway.
Right. Okay, so maybe it's this question. It's pretty straightforward, and maybe it addresses compatibility questions. So the question is, does KeyLines have any special requirements to display a generated visualization for a web page? For example, having to install extensions to the web browser?
Yeah, so by default, we work on all modern browsers, so there's no reason to install any sort of extension. It is kind of pure JavaScript. Now, WebGL does require the right browser and kind of effectively a graphics card. But one of the best things I think about KeyLines is that it will kind of downgrade itself nicely. The real word for that is escape my mind right now. But effectively, what that means is it will show the same view, same sort of configuration of your data, but without using WebGL for those customers or those users who aren't able to upgrade their browser or use modern computers. So yeah, there is nothing that you need to install. All you need to have is a browser, and we also pride ourselves on working on mobile devices, touch devices like Surfaces or iPads as well.
All right. We have time. So for the last question, I think we have time for. Let's see here. So how does data from different data sources, for example, Postgres and Neo4j, show up in KeyLines? Will it show up as two different unconnected node and link graphs?
The cool thing about this is, and it's kind of convenient for us, is that it's really down to you. I mean, you could easily put the same view of data from different data sources. KeyLines is flexible enough that you can bring in data from absolutely anywhere, and you can merge them into the same diagram. But you could also find a use case where you have two separate views from different data sources, and they have some sort of cross filtering. So you select a node of one view, and then the other view updates as well. So the kind of answer to your question is yes, you can do basically whatever you want. And because we don't enforce a particular model in KeyLines, and you just have those nodes and links that I defined, you can basically come up with any sort of model regardless of the backend.
Okay, great. Cool. So thanks for that. I think we'll wrap that up with this. There are a few more questions we don't have time to answer. So what we'll do is we'll get in touch with people individually. Also, of course, if you have any questions, please feel free to contact us. There's various people on the website that you can contact depending on where you're based and what you're after. And also, Christian mentioned that we do provide trials of KeyLines. So if you want to try it out yourself, you get to download and give KeyLines a go. There's loads of help, and we'll guide you through an evaluation as well. So please get in touch with us if you want to try it out yourself. Otherwise, yeah, thank you all for attending, and we'll hope to see you at the next one as well.